Hello everyone, so welcome to this video. We are here to solve the problem of the day. Let's read the problem. Well, the problem we have today is number of distinct sequences. The problem says given a string consisting of a lowercase English alphabets, the task is to find the number of distinct subsequences of a string. And there is one note, answer can be very large, so we have to, give our output in the module of 10 to the power 9 plus 7. Okay, so now let us understand the question by the examples. What we are given just this one parameter, which is one string, right? So we'll be receiving one string and we have to output the number of distinct subsequences. What are subsequences? We have to form all the combinations. Assume you have GFG as a string, then we have subsequences as G, right? F separately, and then the first G and F as well, and the F and G as well. When we talk about subsequences, that means sequence matter, and that is what makes it different from combinations, right? And to understand this example in even clearer manner, let's try to solve it ourselves. So here we have the two sample cases that we had there. Let's try to solve it ourselves. So first of all, when we are talking about subsequences, what we basically mean is that we have to create all the combinations, just that we have to take care of the sequence. So if I say that GF, is it one of the subsequence? Yes, it is one of the subsequence. And if I say GG is one of the subsequence, yes, it is one of the subsequence as well. And if I have to say FG is a valid subsequence. But if I pick up this F, notice clearly, if I pick up this F, or let's take another example. If I say ABC, right, this is a string. I pick up this C and this A. So CA cannot be a subsequence, right? Because when we are talking about subsequences, you need to take care of the sequence, right? So now we know what do we have to find. Correct. One thing more, we know what are subsequences, and what the question demands is actual the distinct subsequences. So we need to take care what are the repetitions happening in the subsequences, and we need to discard those. And we have to return the number. Fine. So if we try to create subsequences for this one, first one would be empty string. Note that we are considering empty string to be a subsequence. So beginning with it, let's consider the string till here. That means we'd be having two possibilities, either nothing or the first character. And then this is the situation when we include F, what will happen? We need to combine F with both of these, right? So firstly, when we combine F with the empty string, then it will be F. And once we combine F with the G, then what will happen? We'll have G and F, right? Now till here we have four combinations, or better said, four subsequences, including the last G. What will happen? We have to combine this G with every possibility. Okay, so combining this G with empty string, I'll again have G. Now notice one thing. This G is getting repeated. So we actually have to discard this. Okay, we'll discard this. Moving forward, combining it with G, we'll have one more subsequence, GG. Combining it with F, we'll have one more subsequence. It'll be GF. Oh, actually it'll be FG. FG. Combining that with this GF, we'll be having GFG, right? Now let's count how many subsequences have we formed. 1, 2, 3, 4, 5, 6, and 7. All right. So how many have we gotten? We have gotten 7 subsequences out of this combination, 7 distinct subsequences. All right. We cancelled one G, right? Because that was one of the possible subsequences, but that was getting repeated. Otherwise, if we would not have cancelled that, what would have been the total number of subsequences? It would have been equal to 2 to the power 3, where 3 is the length of our string. Why is this happening? Again, because when we are forming subsequences, to every character that we have, it has two choices. Either it will be included in the subsequence or it won't be included in the subsequence. Thus, we are making two choices at every point. So we have 2 to the power 3 possibilities. Okay, so we could be having 8, but because we deducted 1G, we are ending up at 7. Okay. Now let's try to do the same thing here, where we are having GGG as our subsequence. Beginning one, obviously we have the empty string. Then we have the first G, right? Now let's combine the second G with these two. When we combine it with the empty string, what will we get? We'll get G. Repeated, we don't have to take that. When we combine it with the already existing G, it will be G, G, right? So we have these three combinations till we have traversed here. Including the last G, what will we have? Once we combine it with empty, it will be G. We already have that. We are not going to consider it. Then we'll combine it with this existing G. It will become GG, but this time we also have acquired that. We do not need to store that again. Then the last thing, we have GG. Combining this G with these two G's, we'll form GGG, which is occurring for the first time. So we'll be considering it. So for this particular string, how many subsequence do we have? How many distinct subsequence do we have? We have 1, 2, 3, and 4. So the answer for this one will be 4. Okay. Now let's try to understand an approach that we can use for this. Okay. So let's consider this string and try to solve it in more depth. For that, you must know how we are considering, how we are making up subsequences. Okay. So let's consider for the first time, that means empty string, right? Or let's better set it 0th time. Okay. So for the G, or you can say the first time we are going to be making subsequences, this. We have to combine this G with already existing ones. What subsequence do we have till now? We have empty string. We have to combine this G with it. What are going to be the two new subsequences? Our empty string and G. So here, when we had 2 to the power 0, that means nothing. We had one subsequence. But when we had 2 to the power 1, how many subsequences do we have? We have two subsequences. Further on, how many subsequences will be here? Possibly 4. How? Let's see. Now, once we are considering f, right, we have two values. We have two characters. What will we do? What are the already existing ones? The empty string and G. We have to combine f because f is the new one. We have to combine f with these two, right? So once combining f with these two, I'll already have these two subsequences. Now combining f with both of these, with empty, it will become f. With G, existing G, it will become GF, right? So for 2 to the power 2, we have 4 possibilities. And now let's include the last G as well. When we include the last G, what will happen? We'll have 2 to the power 3. That means 8 possibilities. Obviously, these 4 are going to be the part of it. So let me write it already. Then what do I have? I have this last G. I have to combine it with empty. It will become G. I have to combine it with this G. It will become double G. I have to combine it with this F. It will become FG. And with this last one, it will become GFG, right? Now these are all the subsequences. These are all the subsequences. How do we have to actually count the distinct ones? We have to remove the repeated ones. So this is the repeated one. I have to remove this G. Fine. Right? So how many do we have now? We have 1, 2, 3, 4, and 5, 6, 7. 7. We have already done this before. Now we know that 7 is the right answer. And now we know how we are making up subsequences in even more clearer manner. But is this the best approach? Is this the best approach? Finding out all the subsequences and then filtering out the distinct ones. Is this the approach that we should follow? Because we would be making up so many combinations which actually is not going to be of any use to us. And what the question demands is how many subsequences do we have? How many distinct subsequences do we have? We actually do not have to create these. We can keep track of the numbers that we are creating. Okay. All right. Now let's notice one thing. Let's notice one thing. Once we are deducting this G, or let's say once we are deducting some of the amount from our total number of possibilities of our subsequences, what we are actually doing. Assume you are here. You have this value 8 because you know when we have 3 characters, we are going to be making 8 subsequences. Now, how many should be deducted? We have to keep track of this in the form of a set or an hash map to check if any character is occurring for the second time or repeated times. So once we know that this G is actually repeating, right? We already know that this G has G has already come before, right? So at what point it has come? It has come at this point. Okay. So this is actually, see what is the number? 1, the first point. So how many do we have in the previous? How many subsequence do we have in the previous of G? Because G is getting combined with all these and it is forming up new possibilities, right? So we need to keep track with how many elements G is getting combined and making the new ones, right? So because this is the same situation, right? You have all these, and you're combining G with it. This possibility is here. See, this is the same possibility. You have your empty string, you're combining your G with it. You have your empty string, you are combining your G with it. We have to avoid this. That means from 8, we have to subtract the previous occurrences index. Okay, the previous occurrences at 1. So what is the value at 1? We have to subtract that from our total number. Okay, so value at the previous occurrence is 2 and 1 before that is 1. We need to keep that and we'll be having our 7 here. Okay, you still might be having some confusion, so let's do it for one more string. Okay, and then it'll be clear in your head. Okay, to begin with, for the 0th time, okay, for the 0th time, that means we have empty string again, correct? 2 to the power 0 equals 1 and the index is 0, remember. Then what do we have to do? We have to say our index has now turned 1 and what are the possible combinations? 2 to the power 1 equals 1, the total possible combinations. Let's make it. Again, we have G. So here empty string is going to be repeated and then G, right? Because combining G with it. Now we have at the second index, what do we have? 2 to the power 2 equals 4. Now I'm including F, right? So let's make the possible combinations. G, we have to repeat these two. Then we combining F with empty, we have F. Combining F with G, we have GF. Okay, pretty similar to the previous one. Let's include H as well. When we are including H, what is actually happening is we have 3 values now. We are at the third index now and we have to write 2 to the power 3, which will end up at 8. That means till here we'd be having 8 possible combinations, or again, better said subsequences, because sequence matters here. Then what do we have to do? We have to again copy these 4 values, right? Change the color. So again, we have empty, we have G, we have F, we have GF, right? We have these 4 values. Now what we have to do, we have to combine H with all of these. So once we combine H with empty, GH, FH, GFH. You can keep a track. Till now, no character is repeated. And that is why we have not deducted any value. It is going as it is. Now let's do it for this F. Now the game changes. Pay attention to it. Now we are at the 4th index and we are talking about 4 values. That means our possibility could be having 16 combinations. All these are going to be getting repeated. So let me just copy that. Okay. All these are going to be getting repeated and we are having it here. But now as you can see, F is actually getting repeated, right? F is getting repeated. Now again we have to make up the subsequences. Which was the position we were adding F before that? It was this one, right? We were adding F before here as well. Prior to F, with how many values did we add F? These 2 values, right? And these 2 values are going to be with us till here as well, right? Do we need to make up the combinations? Because I know when I put F with empty, I'll receive F, which I've already gotten. When I put this F with G, I'll receive GF, which I have already gotten, right? So I have to avoid this thing. I already know that F has occurred prior and just one before F, just one index before F. What is the possible number of combinations? It's actually 2. So it is 2. Thus, we know that 2 is going to be getting subtracted from it. Okay, so what we'll do here is we'll be having only 14 combinations here. How? Let's solve that. Okay, combining f with empty, f, we do not have to record that. Combining f with g, we do not have to record that. Combining f with f, yes, this is a new thing. Combining f with g, gf, it is going to be gff. Combining f with h, it is going to be hf. Combining f with g and h, it will be ghf. Combining f here, fhf, and combining our f here, it will be gfhf. Okay, and let's count again how many subsequence we have found. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. We have gotten that already from our calculations, and this is just to show you that yes, this is actually happening. So what we are thinking is actually happening this way. Let's proceed it with the last h as well. So now for the h, what do we have? We have it at the 5th position. How many possible combinations are we going to be having? Now notice one thing. We cannot say 2 to the power 5. Okay, because we have subtracted some of the values before, right? I was saying to the power 1 to the power 2 to the power 3 till here, and here as well, because at this point we actually subtracted something. So all the combinations are going to be 2 to the power 5, but because we have to keep track of these values. How many values are these? These are 14. These are 14. So now we have to consider all these values plus when h is attached to all these values. That means we are actually doubling this number. So when we were talking about the powers, what we were actually doing was we were actually just doubling the number. Here we do not have to double 16, we have to double 14 because we have made our deductions, right? So once we are here, we have to double 14. So once we double 14, what will we have? We'll have 28. Okay, so this is the number that we are looking for. These are all the possible combinations with h that we have to make. Do we have to make deductions in it? Yes, because h is also getting repeated. Till here, what we have done, we have found all these combinations. We know these many combinations are possible with h. How many are getting repeated? How will we know that? We have to look back. We have to look back that when we encountered h, how many combinations were we making? We were making combinations with these 4 values, right? We were attaching h with these 4 values and we were getting these subsequences, right? And we already have that in a value. We do not want to do that again. So from 28, what do we have to deduct? We have to deduct this value. Okay, we have already made combination of these values with h. We do not have to repeat that. Thus, we'll subtract 4 from it. So till now, we are having 24. And for this question, 24 is the final answer. I hope with this example, with this column and this column, everything would have been clear to you. Okay, let's quickly see the algorithm for it. Okay, so thinking in a more programmatic manner, what do we have to do? We have to create a DP array. Okay, we have to create a DP array of length string plus 1. So whatsoever we receive, we have to create a DP array which is going to be of the length of the string plus 1, and we have to by default add 0 to every index. The first step that we have to do is we have to set dp0 as 1. Why we are doing that? Because we are considering the empty string. Okay, so once we are at the 0th index, that means we are not taking any character. How many possible subsequence do we have? We have one possible subsequence, and this signifies that. Now what do we have to do? We have to actually create a hash map, or you can say dictionary. Why we are creating it? Because we need to keep a track that what value has already occurred, right? And also one more thing that we'll keep in mind is that at what index it has occurred. Okay, so now next, what do we have to do? We have to loop. Okay, we have to loop till the end of the DP. Okay, so we have created one DP and it is having 0 values, 0 as values of every index. We are here and we have set the 0 as 1. We have to iterate till the end and we need to keep on filling these values. Okay, we need to keep on filling these values. How we are going to fill that? Like this. what do we have to do? We have to set the current as double of the previous. We are going to be beginning from here. What do we have in previous? We have 1, right? We will double it and put it here. I've doubled it and I've put it here. Now what do I have to do? I have to check that if the current string character is repeated. If we take example of the previous one where we had GFH, FH. So we are here at G. Now, are we repeating G? No. So that means we are not going to enter this if, and what will happen? What we'll do, add the current string character in hash map or dictionary. I'll have my dictionary, let's say here, and I'll add it. So what is going to be my values that I'll add? I'll say that G is the corresponding key, and to its value, what do I have? I have the number of possibilities, that means 2, the number of possible subsequences, comma, the index. What is the index? The index is 1, right? So I'll write 1 here. So I have to store it in this manner. Okay, so once that is done, I'll be iterating again. Okay, now this time for this particular value. Now, firstly, what do we have to do? We have to double it and store that. I've doubled it and I've stored it. So for F also the same thing will happen, right? Because F is not getting repeated, we are not going to go inside this if. We will add F here. What are the possible number of subsequences? 4. And what is the index? 2, right? Then when we encounter H, same thing will happen. I'll double it and put it here. And now H will be created here with value 8, 3, correct? Now what do I have? I have this F again. I'll check in my hash map, and this time we'll go inside this if. Once we go inside this if, what do we have to do? We have to subtract the values at the index of previous occurrence minus 1. What is the previous occurrence? The previous occurrence of F is at 2. We have to put the value of index 1 previous to it. So we are having F at 2. We are having F here. Okay, let me scroll down. We are having F here. We have to give this value, and here we have 2, right? So what do we have to do? Firstly, we have to double it, right? 8 into 2, it will be 16. How many do we have to subtract? I have to subtract 2 from it. Now it will be 14. Okay, now I'll go to the last character, that is H. For H also, what we'll do, we'll first double 14 and add here. So I have had 20, I have 28 now. And then again, when I go into this if statement, it'll be it'll be true because I've already encountered H, correct? Now again, we have to do the same thing. We have to see at what index H is. H is at 3rd index. That means H is here, correct? Do we have to subtract 8? No. What do we have to subtract? The value that we have created 1 previous to H. What value we have created 1 previous to H? It is 4. So what we have to do? We have to 28 minus 4, and we have to store 24, correct? So it will be 24. And once we are done with our string, once we have reached the end of a DP array, we'll come out of this loop. And what do we have to return? We have to return the last index value of our DP. What do we have in the last of our DP? 24. And what is 24? Our answer, right? Let's quickly just see this code for the same. Okay, so what I've done here is I've created this DP, and it has added 0 as all the values. Fine. I have set the first value to be 1. Just we have seen why. This I is for running my while loop. I've created a dictionary, or you can say a hash map. Then what I'm doing, I'm just doubling the previous value. For filling up the current value, I'm doubling the previous value, and because the question demands, I'm taking modulus of it. Okay, now I know what character am I in, what character am I actually in. If I'm talking about DP is when we are iterating DP is actually one step ahead of our string. So if my string is G, F, H, F, H, and my DP is actually beginning from here. Okay, from 0th, 1, 2, 3, and further on, and it is beginning from here. So this is the mapping. For this, when I am iterating my DP and I'm beginning it from 1, my G is actually at the 0th index, right, of S. So what I'm doing here is I am taking the character. I'm just putting my character in a single variable so that I know which character is actually I'm talking about in this iteration. So in this iteration, value of C will be G, right? Now I'm just checking that if my C is actually existing in my hash map. If my C is actually existing in my hash map, initially it is going to be empty, right? If that has happened, what would I have done? I would have, see, I've actually doubled the value already. So I have to make subtraction. So what subtraction I have to make? I'll be subtracting the DC value. That means DC, what do I have at DC? At DC, I have one index. So what index it is actually at? It actually is at 2, right? So I'll be having 2 here. So 2 minus 1, what will that be? It will be 1. That means I have to subtract whatsoever value I'm keeping here. Correct? That will be subtracted, and then what am I doing here? If my if is not encountered, that means I have not stored my value, and if I'm encountering any value for the first time, I'll simply just add it to my dictionary or my hash map. Fine. So I hope this loop is clear to you now. Once this loop will execute till the end of the DP, eventually we have to return the last value, and we have to put the modulo with 10 to the power 9 plus 7, correct? And if we talk about the complexity, what is going to be the time complexity of it? Okay, so the time complexity is actually going to be of ON, right? Or you can say N plus 1. But we are actually iterating. We are taking the loop from this till whatsoever N we have. What is N? The length of the string. Okay, and the space complexity is also going to be O of N. Again, or you can say O of N plus 1, because I'm taking this extra cell. Why? Because I have to create an array. Okay, I have to create an array just to perform my calculations and to build up my answer. So this is necessary, and this is necessary, and this is actually what our question demanded. So let's try running this code and see if it is actually working. So here we have that code. Let's try to compile it. Okay, so it is getting compiled successfully. Let's try to submit that and test it against all the test cases. Okay, so it has passed all the test cases. So I hope you have understood this problem. Thanks for watching, and do comment if you like the video.